Welcome to 29th lecture in the course of Industrial Engineering and Operations Research. We are discussing many interesting topics related to Industry 4.0 and also Industry 5.0. Now, today we are going to discuss about smart factories, which has become a buzzword, how the production system can be made smart. And this smart factory may not just include production industry, but it also can include service industry. It is basically a term for use of the modern technologies. So smart factories can be called as the future of manufacturing. It basically embraces the concept of Industry 4.0. Now basically it uses things like cyber physical system and IoT. Basically a cyber physical system that uses advanced technologies like AI and machine learning to analyze data, automate processes and learn. That means in one sense you can say that smart factory is a cyber physical system that uses advanced technologies like artificial intelligence and machine learning to analyze data, automate processes and learn. That means lot of data is used in that factory for the automation of the process, for the improvement of the process. These can be the steps that in a smart factory you can collect. There should be something, you should collect the data. One cannot be smart unless one knows that what is going around him, or one learns from experience, then only one can be said smart. Similarly, a factory can be said smart if it utilizes the proper data. Factory is also gaining experience day by day. That experience is basically in the form of data. So data collection is a very crucial part in any smart factory. Once you have collected the data and you properly filtered it also, then you have to do data analysis. And then data analysis, I have already discussed many techniques. You can do statistical inference test, and machine learning methods can also be used. Then with the help of data etc., you can automate processes. Suppose you get data about that some machine, and by that you infer that machine's condition is bad. So automatically you can start its maintenance activity. Similarly, if online also, if the machine is giving some data, then accordingly you can adjust machine's speed etc. And then it can do real time optimization also. That process can be optimized real time, so data can come real time. And then there is a flexibility and adaptability. That means a smart factory is that type of thing which is flexible. Suppose today is the order of 100 pieces, tomorrow the order is of 500 pieces, and the third day maybe 5 pieces only. Accordingly it can, that it should be flexible in approach, and it can adapt also according to the circumstances. If there is some weather changes there, accordingly the parameters can be changed, many things. So one should be flexible and one should have adaptability. Flexibility means if you are making one type of product, but suddenly the demand has come for other type of product, then one should be flexible enough to go to that. And adaptability means there may be some changes occurring, like adaptive control etc., and that one can take care. Integration of technologies, that means number of technologies are there, they are properly integrated in a smart factory system. So what will be the benefits of the smart factory? That benefits are increased efficiency, proper utilization of resources is there, you improve the productivity, and reduced costs. Costs get reduced with the use of the smart factory techniques. Improved product quality also gets improved. Then enhanced responsiveness, that latency is very small, it can respond to any changes, any type of thing. If you give some input, it quickly adjusts the output accordingly. so it is very responsive and better decision making can be made. Okay, you can make the proper decision in a much better fashion. Okay, so if we say that in academic way, what is a smart factory? So we talk about a definition: a highly digitized and connected production facility that relies on smart manufacturing. You can also put here that maybe smart manufacturing as well as smart service. Okay, you can even I add it from my side that it is not only the smart manufacturing but smart services. Okay, so it is not limited to only production type of factories, it is also for service. So highly digitized and connected production facility, basically digital manufacturing etc., they fall in this topic and it relies on smart manufacturing. So key traits are that real time data is collected, then autonomous decision making can be done, and then at the same time you have adaptive process. Whenever suppose you are doing machining and suddenly that work piece has come hard, okay, it has come from a different lot, you have set some parameter, so it immediately can adapt to changing the material hardness etc. So that type of thing should be also there, so the process should be adaptive in nature. What are the smart factory technologies which have to be integrated? These technologies should not be used in isolation. Together they should be used, like 1 plus 1 makes 11. So these technologies are IoT, Internet of Things basically. We have already discussed, we have given one talk on Internet of Things. It connects machines, devices and sensors to collect and share data. Internet of Things are basically gadgets about any things, physical things used in industry which may have some embedded sensors. They collect the data and that data is also shared through computers etc. And then AI means artificial intelligence, then machine learning, then robotics, then 3D printing. These are some technologies. And if we go little at micro level, then we can say that we need sensors, lot of sensors are needed in a smart factory. Then cloud computing is one thing, because you have to do some computation and all these type of things one cannot, each industry cannot afford. So therefore if the data is in cloud, that is much better. And we also take the big data analytics tools. Okay, if you have got big data, this has to be analyzed. And another enabling technology is of course virtual reality and augmented reality, VR and AR. We say VR, virtual reality, and AR means augmented reality. There is a fine difference between these two type of things and one has to understand that. Augmented reality is a digital technology that involves digital information superimposed on reality and viewed via a smartphone usually. For example, you are playing a game and in which that suppose the game is of that type of thing that in your room somewhere treasure is hidden and you have to actually search that. So it is basically you can play this game in a real room. That means you can move and you can try to go to each and every corner here and there and just see that where you get a treasure, and that treasure will not be physically kept, but it will be virtually shown on your mobile phone. As soon as you reach to that location, then you can say yes, there is a, in a screen it will flash out that this is a, here there is a treasure. So like that means you have the real world, on that you superimpose the virtual thing, that means which is in the computer. So this can be called augmented reality. But virtual reality is a more immersive virtual world. There you are not concerned with the room etc. Physical room you don't have to move. You sit at one place, you put some 3D glasses and you see everything like a 3D movie in your screen itself. That is called virtual reality. So virtual reality is that type of thing, that where you do that everything in the computer. And augmented reality is that you augment, you supplement, you are actually going to say real beach, okay, in sea beach is there, but you can actually put maybe in the virtual world you can see some other additional features there, and that can enhance your learning experience. See, you can make a background etc. type of thing. Say for example, if I am sitting at some place and I am giving a lecture, but you can through virtual methods you can give me a feeling of forest etc. you can create in my smartphone, picture of forest etc. can come or something like that. So this is I have given some idea about augmented reality. More examples you will only can know by seeing many such examples, and such type of examples are present in the internet, in YouTube etc., and you can get a good feel about that. Now let us discuss about the levels of smart factory. That means you need basic data availability, that is at first level. That means if you can say very low level type of smart factory is at least provides the basic data, and then you can at one higher level you can do data analysis, and then you can have active data, and then you can have action oriented data, that by means of that you can do online action and it can be useful thing. So here that there is a some diagram which is available in this journal paper. It has shown that what are the different layers in which you operate a smart factory. See, it is a RT middleware. Here you have got fast Ethernet wireless network. Here that actually they are plug type of robot, that means they are the robot and they can put, this is basically the hardware type of layer. Then this data can go to internal cloud of this one, and finally it can go to manufacturing execution system, and finally it can be transferred to various departments over the cloud, remote factories etc. So these are the different type of issues. But before we discuss more about this thing, let us see that how come that that this concept of a smart factory has come, which you can say smart factory is one specific feature of industry 4.0. So industry 1.0, as you know that it deals with the mechanization. It was basically started in late 18th century and continued up to the early 19th century. This is mechanization was the main focus, and people used the water power and they also used steam power. And industry 2.0 was about the mass production, electricity. So mass production was the main feature. You know that industry 2.0 mostly that in the later part of or towards the end of 19th century and maybe beginning of just 20th century, their mass production etc. Those days that Ford motors etc. were very popular and everybody started affording cars. They became affordable by common person, not only for princes etc., but even for common public. And electricity also was used quite frequently. Lighting etc. became very easy. People could work in the night also properly. So this was the feature of industry 2.0. Industry 3.0 deals with automation, and this is CNC machine etc. were of course started in around something like after 1950 or around that time, up to 50, 56, 57 you got this one. But robotics etc. Came into factories in 1970s. So maybe you can say the era of 1970s etc. when we used to have a lot of automation, use of robots etc., use of lot of electronics and information technology. That was industry 3.0. and today's age is basically industry 4.0, which is characterized by cyber physical systems, CPS, and IoT. These are the two main things, of course, which are part of the smart factory. In fact, smart factory itself can be called a cyber physical systems. So many times people may confuse that what is cyber physical system and what is IoT. Therefore, I must explain this. Cyber physical systems are basically collection of computing devices communicating with one another and interacting with the physical world via sensors and actuators in a feedback loop. That means there are physical objects which that transmit data. They are basically controlled, means their brains are basically in the computer and they are properly controlled, and you give a feedback. Control is very important part of that. One example of a cyber physical system can be called as self-driving car. That means car is going and I have left, so naturally how it will go from here to, maybe suppose I am in Guwahati, now from Guwahati to Kolkata I want to send my car, it will drive. So it will have that data through GPS, etc. It keeps getting the information about the location and that information, and then about decision, etc. It is done in the cloud through internet. Any place it goes, it can be controlled, and if there is it has to do some edge computing also. If there is some suddenly that some other scooter comes in front of that car, so the car will sensors will recognize that obstruction and then they will steer the direction. So this has to be done online there itself. There is no time that it sends data to my Guwahati office and then I take the corrective action. It has to be done there itself, but there are many informations. Say for example, I can give a command that take rest at this place, stand in this dhaba or stand in this petrol pump and fill up that thing. All those type of things can be done. So this is basically self-driving car. And so this is cyber physical system example. And what is Internet of Things? Mostly it is not that much in control, but it is mostly in getting the information in the net. So IoT describes the network of physical objects with embedded sensors, software and other technologies. Okay. So it is provided, each device is provided a unique identification and allows data to be transmitted over the network without human interaction, objects to collect and exchange data. So it's basically collecting the data and giving information. Control part is not that much in that. So I am just making a comparative table of CPS, this means cyber physical system, versus Internet of Things. So CPS monitors and can monitor and control the physical processes in a seamless manner. Is that focus, that monitoring and control, you get the information, you take action, whereas IoT just needs a network of interconnected devices to collect and exchange data. Like we may have some weather stations, we may have in some pond I can put some device and which can tell that water quality, that data can always come to me. My fridge also can act as an IoT, that it can just send me the information in mobile that how much thing is in the stock and whether vegetable has got exhausted or not. These type of things can be done. So you can say perhaps that IoT is a part of cyber physical system. That type of thing can also be said. Cyber physical system is integration of physical and cyber components like robot and connected internet type of things. They are connected, whereas IoT is network of interconnected devices. That means they are just giving different type of informations, various devices are connected, and CPS is actually more complex and IoT is somewhat relatively simple. In fact, suppose you put RFID tags in the books also, then this can also be called an IoT device, okay, because you will know the location of that. Suppose I have my smart umbrella, it can also tell about the weather information, etc. So that can be IoT device. So basically CPS requires sensors as well as actuators to execute that thing. That means there is a cyber physical system, computer type of thing is there, but it has to be properly actuated like a smart car. So car will naturally contain many sensors and many actuators, means like motors etc. and other devices which will convert your signals into the muscle power or mechanical work. But in IoT mostly you have embedded sensors, so that can act as IoT device. Okay, that something like that type of thing, like a blackboard which can actually send the data whether it is dirty or not. Those type of things can also be there. So CPS is basically cyber plus physics, means cyber means computer related, internet related things, and IoT means internet, which symbolizes connectivity, and means another thing is things, that means things are interconnected. So key enabling technologies of smart factories are both internet of things, then cyber physical systems, artificial intelligence and machine learning, then cloud and edge computing. I have told you that cloud computing means you have data about in the cloud. That means there is maybe some central place that where you do all the computations, and that computation is transmitted through internet. Or you can have edge computing, that means right at the physical location you do the computation. Then big data analytics, then robotics and automation is also one thing, and digital twin. Nowadays we are making digital twin. We will speak more about digital twin later on, and 5G connectivity, as we know that it is very important for data transmission etc. So edge computing, as I have been telling, that it is a distributed computing framework that brings data processing and storage close to the source of the data, often at the network edge where users and devices access it. So why we do that edge computing when everything is in cloud? Suppose I have 10 factories, I can take this decision that all the computations needed in these factories will be done at one central place, and then the information will be in the internet, and anytime anybody needs it can download from there. If somebody wants to do some computation, it can always send a signal through internet, and it can come to a main station, and in the main station the computations can be done, and finally data can be sent. But this process will take time, so it will have lot of latency. So we need that some bigger decisions etc. which can be taken in a slow phase manner. That is okay, that we can do that way, but quick decisions have to be taken. So therefore some computing type of facility should be there right at those factories also. So that is called edge computing. It reduces latency. Latency is a technical term, technical jargon you can say. It is used mostly in IT sector and computer sector. So it is basically delay and time lag between request and response. You request something but you get response comes late, then we say that it has high latency. So now we discuss smart factory architecture. So in smart factory there are layers. We can talk about different type of layers or different type of levels. So physical layer, sensors and actuators. The network layer, we need connectivity, 5G, Wi-Fi and LoRa, long range that connectivity. Then data layer, storage, databases, application layer, dashboard and analytics, and cyber security as a class layer concern. That means cyber security is needed everywhere. So real time monitoring with IoT can be done. It is basically use of sensors and devices to collect machine data. Example, temperature, vibration, energy uses. Data helps in productive maintenance and efficiency. Say for example, this is a rolling mill and I can fit a camera etc. here. That thermal imaging camera can be there, that can give the information about the temperature. So many type of such things can be done. Digital twin concept is basically, it is a virtual representation of a physical process and system. It enables simulation, monitoring and optimization. Example, simulating a factory line before actual production, and this can be like that. Suppose this is digital twin DT and this is a physical system, this is PS. So digital twin is just like physical system whatever, and there is a two-way communication also here. That means this data can be transmitted from physical to digital twin, and digital twin can take the corrective action. AI and machine learning applications also are part of smart factory. Predictive maintenance based on the sensors feedback etc. You can predict whether there has to be need of any maintenance etc. So that is can be done. Quality inspection via computer can be done. Computer vision can be used. Process optimization, online process optimization can be done. Say for example, this person is seeing in the screen the process, and it is giving that some command by which initial conditions are going, velocity, feed etc. Then output is getting measured, and based on that feedback he is again adjusting, or maybe computer itself is adjusting the things. And then demand forecasting means work related to industrial engineering and marketing etc. Okay, that type of thing also can be done. So we can discuss that there are various persons we have used, various factories have used, and we can see lot of case studies in business magazines etc. in the internet etc. I encourage you to see that, but here I am just giving you that some very brief summary about that, and you can go to that company's website, you can search in the Google, you can get much information. Like Bosch Smart Factory, Germany and India, what they do, they use IoT sensors, AI and predictive maintenance, and because of these things, particularly using the predictive maintenance etc., they reduce downtime by 25%. Otherwise maintenance activity takes time, but here downtime got reduced and improved quality control, and it is located, this factory is in Germany and in Nashik, India also. Okay, and you can get information about various sources. Then Siemens Ambal plant, Germany, what they do, that they produces Siemens automation products. Key features are that over 75% of the value chain is automated with a defect rate of just 12 per million, and it considered a global model for industry 4.0. And then you can see that GE Brilliant factory is also there. They combine advanced analytics with lean manufacturing. So concept of the lean manufacturing, that where you reduce the wastage, you keep the resources minimum. If I am giving a lecture and I have got a big hall which has got a 500 seating capacity and only 2 students are sitting there, it is not a lean system. So lean system means that it reduces the wastage, because in that big hall I have to switch on lights also. Just for 2 students there are 5 tube lights are on and fans are running. This is not a lean system. So similarly in the companies also, lean means it should be lean and thin edge and whatever you do that. So with the help of analytics they understood that how wastage can be minimized. Key features are use of digital twins, real-time data and AI for process optimization that you can do. And then Tata Steel in Odisha, Kalingnagar, they do implemented smart sensors, AI ML for quality control and maintenance, and they do real-time control over blast furnace operations, improving energy efficiency. So these type of things were also done. And then Senidal Electric Smart Factory, it is in Hyderabad. They used industrial Internet of Things enabled platform, and real-time energy monitoring is done, and predictive maintenance also becomes the part of that. So these things can be done. And what are the benefits of smart factories? We get improved efficiency and uptime, enhanced product quality, reduced operational cost, better energy management and greater flexibility and customization. Customization means depending on the customer's requirement, you can make the product. There may be 100 customers and 100 persons are purchasing different type of products, but each one according to the need, it can be easily adapted. Customization is facilitated by additive manufacturing etc. also, where core that software things are there, and finally they can adapt according to the need of the person. So this is customization. It is not that one size fit for all, but everybody can choose the product depending on one's liking and disliking. Of course, the basic features may remain same. So these are the benefits of this one, but what are the challenges in implementation? One is that it is high initial cost, other is the cyber security vulnerabilities. Cyber security issues are there, then workforce skill gap is there, you need to train a lot. Many people don't even understand these names and terminologies, so it will take time. That's why I am trying to create awareness through these type of talks. Of course, we are not going in much depth, but at least you will know that this is IoT, this is this one, and your fear will go. And then integration with legacy system, that means some companies are working all over of a sudden. We cannot throw out old machines, but we can slowly upgrade those companies to smart factory. So that means that is called legacy system, that which is coming through generations. So that legacy can be actually changed, and data ownership and privacy are the issues. Okay, so how to use a legacy system as well as integration with the new system, that is also one challenge. So these are the challenges, and future trends are that basically integration with quantum computing. Nowadays people are talking much about quantum computing. I am not going into that detail. In fact, it is not very clear also that much that how it works, but you know that this is taking the trend, and it is a highly new topic where the computing speed can be very fast. And human robot collaboration, which is the part of industry 5.0, that is also there, and sustainable and green smart factories is also focus of industry 5.0. So this will also be done. So basically, to conclude, that smart factories are intelligent, adaptive and data driven. They transform traditional manufacturing, and we need a roadmap for adaptation. Technology is needed, training is needed, and then we have to do transformation. So this is thank you this much. Okay, and we will discuss other topics, okay, in the next lecture.